Hi there, I'm Pedro from team number 2 of this course of Materials Behavior. Follow me into the lab so I can show you all the amazing equipment we have over here. The downside of this part, the foundry area, is that we're not going to use them until later semesters, but it's still important to know how they work and operate. Over here we have the smelter that reaches 1500 degrees. It is used to melt aluminum, copper, and low melting point metals. It gets quite hot. We are not going to be using our safety boots on this semester because we're not going to use it. Here we have the smelter. Now, the most important characteristic of this smelter is that we are not allowed to use aluminum to clean any foil left maybe after cutting any other metal.
Welcome. As you can see here, we have our cutting apparatus. Here we have a more industrious cutter that we are not going to use because it's not meant for cutting metal. And here we have our baby. It has a ceramic blade. It is a silicon oxide. And as you know, ceramic are one of the strongest materials, especially for cutting. It has two tubes that inject coolant into the cutting process so that the material we're cutting and the blade don't heat up and don't make a mess.
Hello, this is the preparation area where you're done with the foundry and cutting your metals and all your pieces. Then sometimes the metal is too small to work with, and here's where you prepare it so you can work with. Here you're going to cover your pieces with bakelite. It starts with this white dust you see here. You will pour this dust inside this tube, and this machine, it has a hydraulic jack inside, and you're going to use that jack to increase the pressure, and you will put electric resistance here to heat it up, so you can cover your piece in bakelite, and then it's easier to work with that piece.
Right here we have the microscopes. Now, we're not calling them microscopes. Hi, we have the microscopes over here. Amazing. Now, we're not calling them microscopes for the sake of convention. Oh no. Micro means micron, the unit base of 10 to the minus 6. That's a lot of detail we can see over here.
These three machines will measure the hardness of the material. This first one, that is the beakers, will measure it in a microscopic way. These two that are the Rockwell will measure it directly. And last but not least, the Brinell will measure it microscopic or directly, depending on the table and the specifications.
And continuing on the preparation area, here is where you will finish your piece ready to be used. Here you have three machines, the three of them work the same way. Here's where you will polish your piece. We have here the alumina to polish it, and then on the other side of the machine, here's the grinder, and here you will use some sanders to. But the problem of that is that it will have an opaque, let's say, face to the bakelite. So to finish it all up, you will use these chemicals that will give you a transparent look to the piece, and then it's ready to be used.
Well, here we have the mechanical test zone. Here we have a machine that is a pendulum. It's an impact machine test. In the one that we use or we put a material in the low part of the pendulum, and it measures how much the the material can absorb of energy. Here we have a electromechanic static machine. In this one we can measure the elongation of the material, the deformation, and other things that we can have in graphs. Here in the computer we have extensometer that we put a half of inch over the static arm and the other in the hydraulic arm in order to measure the material.
This is an electric furnace. It can reach 2100 degrees and is designed for industrial purposes. You can melt low-density metals such as copper, aluminum, and steel.
Thank you for joining us through our introduction to the mechanical laboratory.